All right, this video is about 3.1b graphing exponential functions. So yesterday you used Desmos or some graphing calculator to graph and compare a bunch of exponential functions. What we're going to do today, basically we want to not use the calculator. We're going to use our knowledge of transformations and parent functions to graph the exponentials. So one thing that's a little bit different about parent functions of exponentials is that we can change the base number. So for example, I could have y equals 4 to the x power, or I could have y equals 2 to the x power. These are both considered parent functions, even though the 4 and the 2 are different, because that base number is not considered a transformation. It's just part of the function. The type of transformations we're going to look at today are going to be like if I added a 1 up here or subtracted a 5 down here. So really we're just doing plus or minus number on the inside, which moves the function right or left. And remember, it does the opposite sign. Or we're doing plus or minus 5 on the outside. If it's down here, that means it's on the outside, and that's just going to move it up or down. That one goes the direction you think it would. So in order to do that, we need to think about the parent functions first so we know what we're transforming. So as we looked at these yesterday, the parent functions always have what's called a horizontal asymptote at 0, at y equals 0. It kind of hugs along that line. All of them, when they're a parent function, they go through this point, 0, 1. Okay, think about that. If I plug 0 in for x, I'm going to get 4 to the 0 power. Anything raised to the 0 power is always 1. So that's why these always cross at 0, 1, because no matter what the base number is, if I put the exponent at 0, the y value is always going to be 1. So it will always cross at 0, 1, and the horizontal asymptote is always going to be at 0. And then if it's a parent function, that's if it's not been transformed, right? And then the other point that's always there is that if I plug in 1 to this, what am I always going to get back? I'm always going to get back whatever the base is. So in this case, 4. So I also know that 1 base, or 1 in this case 4. Oh, whoops, 1. Okay, I've messed it up already. Okay, let's try this again. All right, so I have 0, 1. That's always going to be there. And then 1, 4. So 1, 2, 3, 4. And of course, it's not completely lined up the right way because when I drew it. But 1, 4, or 1 base will always be on the function as well. So now if I had y equals 4 to the x plus 2 minus 3, this is the function that I would be moving left 2 and down 3. And specifically, those 2 points, 1, 4 and 0, 1, those are what I'm moving. So on the original, okay, I had 0, 1. So 0, 1 is going to go left 2 and down 3. So here I have 0, 1. If it goes left 2 and down 3, it's putting it at -2, -2. Okay, and so on your assignment, when I say put 2 coordinate points, I'm talking about once you've transformed 0, 1, and 1 base, those are going to be the points you're going to write down. So there's the first one. And then we are going to do our point that would be 1, 4. That one also has to go left 2 and down 4. So that one's going to be at -1, 0. So those are my 2 coordinates. My horizontal asymptote that was at 0 is also going to go down 3. So now it's down here at -3. And so my function's going to hug that, and then it's going to go up like that. Okay, so let's do the same thing with y equals 2 to the x. If it's just 2 to the x, that's just the parent function. And so it's always going to have the 2 points 0, 1 and 1 base. So 0, 1 is always on these parent functions, one base, and then in this case the base is 2. So 1, 2 is also going to be on the function. So if I'm right now I'm just graphing this parent function y equals 2 to the x, so I know there's a horizontal asymptote at 0. Okay, always true if there's no transformations on these, if the only number you see is the base and the only exponent is an x. So 0, 1 and 1, 2 are the 2 points on here. It's going to hug that horizontal asymptote and it's going to go up through. Okay, so now if I had y equals 2 to the x plus 2 minus 3, oops, I did the same thing, so let's not do the same thing. So let's instead say x minus 1 and then plus 4. Okay, so now think since my base here is 2, this 2 to the x, that is the parent function that I'm transforming. So that point that's at 0, 1, that point that's at 0, 1 is going to go right 1 and is going to go up 4. So if 0, 1 goes right 1, that means the x value is going to have 1 added to it. If it goes up 4 from y equals 1, 1 plus 4 is 5. So 1, 5 is on the graph. Again, if I can also just start by counting right here. If I'm at 0, 1 and I go right 1 and then up 4, it gets me to the same place, 1, 5. The other point that would be on the graph is 1 base, so 1, 2 in this case. So 1, 2 is also going right 1 and up 4. See, my graph is just not very well drawn, so that's why I'm going to actually just add 1 to the x value, and I'm going to add 4 to the y value. So 2, 6 is my next point. My horizontal asymptote is always at 0 on the parent function, but since this went up 4, it's going to move up to 4. And then just sketch the graph. Okay, let's just do one more. So if my function is y equals 5 to the x power, okay, first I'm just doing the parent function. So on the parent function, that horizontal asymptote is always at 0. I know it's going to cross at 0, 1 and at 1, 5. So I know it has these 2 points on the graph. Okay, so if y equals 5 to the x gets transformed, say I have x minus 3 and then plus 2. Okay, so I know that my horizontal asymptote is going up to 2 because everything went up 2. The point that was at 0, 1, so it was right here. So the point that was at 0, 1 is going right 3 and up 2. So it's now going to be at 3, 3. Again, take the opposite sign of that, add it to the x value. 0 plus 3 is 3. Add 2 to the y value is another way to do it. Okay, and then the point that would, so that was on the transformed, so that was on the parent function. The transformed coordinate is 3, 3. Okay, 1 base, or 1, 5 in this case, would also be on the function. If I move it right 3, that's going to add 3 to the x value. If I move it up 2, that's going to add 2 to the y value, so 4, 7. Again, you can also do it by putting your pencil on 1, 5, which would be here. And then you can go ahead and move right 3 from there and up 2, you're going to get the same point, the 4, 7. Okay, so again, write down those coordinates, the 2 points you transformed. So in this case, 3, 3, and 4, 7, and then just sketch the graph. All right, guys, if you have any questions today, just email me and I'd be happy to answer them for you. And I hope you have a great day.